that you're given a picture of an angle, and let's put it in quadrant 2. So here's the picture of your angle in quadrant 2, and this is going to be considered your theta. And the information that you're given is that the cosine of theta equals -4/5. And it asks you to find the sine of this angle and the tangent of this angle. Now we know that if we were to create a triangle from our angle here, that because I'm on the unit circle, this radius is 1, and it's telling us that the cosine is -4/5. So if I were to plot this point, it's going to be -4/5, comma, and then whatever the sine is of that angle. It's a little bit complicated to have to deal with this triangle with fractional sides and the radius being 1, or the hypotenuse of the triangle being 1. So what I'm going to do is I'm going to kind of blow up this triangle over here and just say that I'm going to use the definition of cosine as being the adjacent side over that hypotenuse. So I'm actually going to call this -4 and this 5. Okay, I'm eventually going to get to the correct answer, but I think I'd rather use this picture than having to deal with fractions. So if I'm looking for this opposite side here, I'm just going to use the Pythagorean theorem. So I'm going to say that a squared plus -4 squared equals 5 squared. So a squared plus 16 equals 25. A squared equals 9. So therefore a equals 3. So the sine here is going to be the opposite side over the hypotenuse, so 3/5. So I'm just going to label that here on my picture here, 3/5. Right, and the tangent is going to be opposite over adjacent, so that's going to be -3/4. Okay, now the really cool part is that using the Pythagorean theorem on this triangle, not on the circle here, worked out really well. But also, given our last video, if I did the Pythagorean theorem on 3/5 squared plus -4/5 squared, I should get 1. So I'm going to get 9/25 plus 16/25, and that actually equals 25/25, which is cool because that also is another way of proving that sine squared plus cosine squared equals 1. Great job, everyone.